Dear students, welcome back. Today we will discuss transmission lines, impedance matching. What is impedance matching? The impedance matching occurs when the load impedance equal to the characteristic impedance of the transmission line. When the load impedance is equal to the characteristic impedance Z0, under this condition, the reflection coefficient is equal to 0. Why? Because there is no reflection occurs when the impedance matching is achieved, and the maximum power is transferred to the load. The reflection coefficient under matching conditions, when ZL is equal to Z0, the reflection coefficient is equal to ZL minus Z0 divided by ZL plus Z0, that is equal to 0. The reflected voltage wave disappears and only the forward traveling wave exists. Under this condition, the voltage standing wave ratio is given by VSWR is equal to 1. Since the reflection coefficient is equal to 0, this means the voltage is uniform along the transmission line. Why impedance matching is required? Without impedance matching, the reflections will occur in the transmission line, standing wave will form, and the power is lost. With impedance matching, maximum power is transferred to the load, no signal distortion, and efficient transmission is achieved. Impedance matching methods, there are two types of impedance matching methods we can achieve in transmission lines. One is quarter wave transformer, second one is a stub matching. What is quarter wave transformer? The impedance matching using quarter wave transformer is shown here. Let us consider an unmatched transmission line where the load impedance is not equal to the characteristic impedance of the transmission line. That is, ZL is not equal to Z0. Therefore, the reflection coefficient is not equal to 0. In this condition, the impedance matching is achieved by using a quarter wave transformer line, quarter wave transmission line. The length of the transmission line is lambda by 4 here. This Z0 dash is the characteristic impedance of the quarter wave transmission line, and ZIN is the input impedance of this quarter wave transmission line, and ZL is the load impedance. And we can achieve the impedance matching by adding this quarter wave transmission line to the actual transmission line with characteristic impedance Z0. Therefore, under the impedance matching conditions, ZIN is equal to Z0 dash whole square divided by ZL. Therefore, ZIN is equal to Z0. If the load impedance differs from Z0, a quarter wave section can be used. Here, the length of the quarter wave transmission line or transformer L is equal to lambda by 4. The input impedance of the quarter wave line is ZIN is equal to Z0 dash square divided by ZL. For matched transmission line, ZIN is equal to Z0 and reflection coefficient is equal to 0. For matching condition, Z0 dash is equal to square root of Z0 into ZL, where Z0 dash is the impedance of the transformer section. Now, stub matching. Uses of open or short circuited transmission line sections, we can achieve impedance matching. The stub matching are two types, single stub matching and double stub matching. By using this, we can cancel the reactive components of load impedance. Single stub matching. Single stub matching is a technique used to match a load impedance ZL to the characteristic impedance Z0 of a transmission line using a single stub or a short transmission line section. Here, ZIN is equal to Z0. Therefore, the reflection coefficient is equal to 0 and voltage standing wave ratio is also equal to 1. What is a stub? A stub is a short section of transmission line terminated by a short circuit or a open circuit. It provides pure reactance or susceptance. Types of single stub matching. Shunt stub matching, most commonly used one. Stub connected in parallel uses admittance method. Second one is series stub matching. stub connected in series uses impedance method. Here we can see open circuit shunt stub, open circuit series stub, and this is short circuited shunt stub and short circuited series stub. The principle of operation here is matching is achieved in two steps. First one is move a distance small d, move from the load to a point where y is equal to g plus jb. Second step is add a stub. A stub provides y stub is equal to minus of jb. Thus, the total admittance becomes y total is becomes g, and minus jb and plus jb will get cancelled. For matching, g is equal to 1 by z naught. The reflection coefficient here is ZL minus Z naught by ZL plus Z naught. The input impedance ZIN is equal to Z naught into ZL plus JZ naught tan beta L divided by ZL Z naught plus JZL tan beta L. The input impedance of the stub for the short circuited stub, it is the input impedance is JZ naught tan beta L. Open circuited stub, Z stub is equal to minus J Z naught cot beta L. Now here we can see subtype and characteristics and its uses. Short circuited stub terminated in a short Z is equal to 0, more commonly used in practice because the short circuited stub is physically easier to realize. No radiation leakage, lower loss than open circuited stub. The input impedance is purely reactive. Similarly, the open circuited stub terminated in an open circuit, that is Z is equal to infinity, used when a short circuit is difficult to implement. Example, microstrip without bias. The input impedance ZOC is equal to minus J Z naught cot beta L. The shunt stub connected in parallel with the main line works with admittance most widely used topology in microstrip and strip line circuits. Similarly, series stub connected in series with the main line with the impedance used in coaxial cables and two-wire systems were common in planar circuits. The advantages here is simple and they are economical, suitable for RF and microwave circuits, adjustable tuning is possible, no lumped components required. Disadvantages: requires physical adjustment, frequency sensitive, not suitable for broadband matching. Applications: they are used in antenna matching, microwave circuits, RF amplifiers, radar systems and communication systems. Here the comparison table, the quantity and uh, the representation here, impedance symbol Z, this is R plus Jx, the units are ohms here, the similarly the reactance, admittance and susceptance. Now low loss radio frequency transmission lines. The students will discuss low loss radio frequency transmission lines in our next class.